After verifying this layout against the circuit schematic and ensuring that the circuit is precisely laid here, we have to look at the physical side of the layout itself. By that, what I mean is that the component sizes, the pad and the hole sizes, the placement, the orientation, and the aesthetics, everything is what I want it to be. So, to do that, we are going to print this layout in the proof format. So, this is meant for placing the components on the printout and measuring for the sizes. It's going to print the actual size in the current colors for both top and bottom layers. So, if you see the preview here, this is the top and this is the bottom. There are two things I want to correct here though. One is it's going to print the silk screen in the yellow color. So if I print it on a laser printer which is black and white, this yellow is not going to be dark enough for me to actually see the outlines of the components. The second thing is the holes are now going to get printed in black and the pads are going to get printed in red. On the black and white printer, the red and the black are going to be very close in color. So I'm going to find it difficult to locate the precise center of the hole. Alright. The idea is that we are going to print this on a paper. We are going to make the holes first using a pin and then easily place the components through the holes. Now, why I want to do that is to try to get this printout as close as possible to the actual PCB itself. So I don't have to force the components in. I can just push them through the holes and place them in the where they belong. So I'm going to make a few changes here. I have to change the top silk screen and the color of the holes. To do that, I'm just going to come out of the print option. I'm going to go to colors, layout colors and visibility. The hole size color, I'm going to change it to white. And the top silk screen, I'm going to change it to something darker. Maybe I'll choose a blue here. Alright. Now when we do the print here, in the print preview you will observe that it's red and the white. I can see the center of the whole actual hole and the top silk screen layer is blue, so it's going to print dark enough. So I'm just going to say print. I'm going to click on print. The other aspect here when we choose a printer is we need to ensure the size, alright? Because if I'm going to print on an A4 sheet and then I'm going to choose letter size, the printout is not going, it might get stretched or compressed. So it's not going to print the actual size. Because I'm using an A4 size paper, I have chosen A4 size here and then I'm saying print. This is what I was referring to earlier. Now I printed this top and the bottom. You can see that you can't see the top screen. Alright. So I made that correction first. And then I got this printout. When I changed the top silk screen from yellow to blue, now you're able to see the text. But again, now the pads are in red and then the holes are in black, so you can't see the center precisely. So we moved on from there and we got a printout like this, where on the top side you can actually see the holes center points precisely. This is where we are going to make the holes. So this is the setup I have created to be able to do the holes on that. So I have a tube light on which I have placed a glass plate on some support. I'm going to use a styrofoam base, what we in India we regularly call as thermocol. So I place the printout on the thermocol and I'm going to use a pin to pierce the holes, something like this. So I'm going to precisely pierce holes for all the components. Right. So styrofoam base allows me to ensure that there is a surface on the underneath my sheet. So I'm just trying to make the hole as big as the print holes in the printout itself. So we're going to continue to do this for all the components. Of course, because this is a manual process, it is prone to little human error. So to avoid all that, we are trying to do it a little patiently. Okay, now that the holes are pierced, I'm going to start mounting the components on the PCB. Okay, now that we are seeing that after placing the components, all the components seem to fit within the footprint that we have chosen. So it's a really nice thing. The only discrepancy I see is about the RMC connectors. So to be more precise about what I'm saying, so if you see here, it's a little wider than the footprint that we have chosen, and it's thinner than the actual RMC is thinner than the footprint we have chosen, but it's a little wider. So we're going to just replace that one particular item. So to do that, we're going to use a vernier calipers to measure the dimensions and then make the corrections accordingly. So this is the RMC that we are going to use. So I'm just taking a vernier to measure the dimensions of the RMC itself. So that's about 10 mm in the length, and the width is about 6 mm, right? And from the edge, you see that it's not in the center. The pins are not in the center with reference to the width of the RMC connector. So we are going to measure that also. Now that's about 2.2 mm from the edge of where the notch is. So we're going to use these dimensions. Basically, we're going to take the RMC, design it like this. We have the notch on the side. We have 3 pads. These are going to be in the center. Each is going to be 2.54 mm apart. So that's not an issue, and it's going to be in the middle with reference to the length. This length is about 10 mm, and this is about 6 mm, and from the edge of the hole to here we want it to be at about 2.2 mm. So we are going to draw the footprint for this accordingly. Alright, now we saw that the RMC didn't match what we want, so it was a little, it had to be a little longer here, right? So if you choose, I'm just going to ungroup the components first. I can pick the RMC alone here, right? This was not wide enough for us, right? So I'm going to open the footprints file where we have already created an RMC footprint based on the dimensions that we measured now. Okay, I'm going to go to the footprints file now, and on the footprints file I need this particular component, which is a 3-pin RMC, right? So I'm going to choose this component, I'm going to copy it from here, I'm going to go to our file and I'm going to paste it, right? So I'm just going to move it to where the actual RMCs are, so I can I'm going to rotate this by 90 degrees and try to align it properly here. The closer you zoom it, the more precise your positioning can be. I see that we have also chosen a bigger part size also, that's fine. But now if you see here, this is the older footprint, right? We noticed that the RMC was wider than we needed, so I kept it like this. And this we can now delete the older one, make the joints on the newer file, newer component. Now this is not exactly placed, right? So we can just move it a little more so that this comes to a precise direction. This is not at 270, so let's move this further to the left and make it 270. Right, so maybe we have to move this a little more. Perfect. Now here the hole is where the lead of the resistor is going to end, and the RMC, this part of the RMC is plastic, so we can actually leave it the way it is, but you know, we have our obsessive compulsive disorders, so we are going to move this a little more. So I'm just pressing control, which you don't see me doing. I'm just choosing all the components that have to move with the RMC. So I'm moving it a little more to the right because I do have space on the PCB anyway. My PCB ends here, so I'm just moving this a little more. So that's it. So what we can do is we can copy this. I'm doing a copy of the RMC and I'm going to other RMC where the correction has to be made. Right. I'm pasting it here. I'm just going to align it properly. Try to get it as correct precisely as possible as per my judgment at this moment. So here also there is a little overlap, so I can delete the older one, join the components here. Now this is at 180, so I have placed it vertically in the right place, but this is not at 90 degrees. So I'm going to zoom in a little more and move this pair of joints to the left a little more so that it's precisely at 90 degrees. Maybe I should zoom in a little more to make that precision. 90, perfect. So this is at 360, this is at 180, this is at 90. So now again the resistor, it's not in place. It's I want to move it accordingly. I'm going to choose the components that I have to move with it. Move it a little more to the right, like I did with the other RMC connector. I'm just going to stop there, move the 10K a little more outside. Alright. So that should do. I'm not going to walk you through the whole printout and the whole process again, but I have verified it earlier also, so I know that this will fit properly. So just going to move on to the next step in the PCB fabrication process. Now that we have verified the layout is correct, we are going to move on to the next step in the PCB fabrication process, which is to print the top and bottom layers on a photo paper, a glossy photo paper, not a matte finish, a glossy photo paper. So we can transfer the image onto a copper clad using the heat transfer method. So we are going to use the transfer edge method here to print it. So if you see the description, it says to transfer the laser printer toner onto the copper clad. Alright, that we can use for etching. Now this has to be done on a laser printer. You cannot do it on an inkjet printer. Alright, and the process is going to print the actual size in black. It's going to print both top and bottom copper layers, and the printed image is going to be mirrored. What do I mean by that? So if you look at this, you see that the text is all flipped. Alright, everything is flipped. A mirror of what we actually saw on the tool when we were designing it. Everything is mirrored. So when this image is transferred onto the copper clad, you're going to see the straight image. So here it's going to be a mirrored image. Alright, now before we do the print directly to a printer, we want to print it to a PDF or some other format, soft copy, so I can open the tool, the layout in another CAD tool, because I want to include the company logo and things like that. Alright, so I'm going to print it to a PDF. Alright, so it's going to ask me where to save it, so I'm just going to give it the same name, G Karthikeya Power Supply version 1 15/10/2020 PDF. So it has been saved as a PDF. So when we open the file, you will see that the PDF has been created. So this is the file. Alright, so the mirrored image is what we have on the PDF. Alright. The software I am using to open the PDF is CorelDRAW. What I have on my PC is version 5x5. So I'm just going to open the file, the PDF file. It's going to ask how to import the text. I'm going to say import it as text itself instead of individual lines and curves. So this is the actual file. It's in the letter format. I want it in the A4 file size. So I'm just going to select everything, group all the pieces, cut it, change, and then I'm going to change it to A4 and paste it back. So now the printed image won't be skewed because my glossy photo paper is in A4 size, and if I print a letter onto the A4 size, it might not come properly, and we have seen that with our experience in the past. So I have changed the paper size to A4. Now, the whole point of bringing it into CorelDRAW was to add our company logo and more information on the PCB itself. All right. I don't need to do it on this PCB because it's for a guided self-study. But hey, nothing wrong in branding ourselves, right? So I'm just going to import the transparent logo, because our logo is very big, but I'm going to make it smaller. Now it's about 13 meters long, so I'm just going to change it to like 16 mm. It's locked, so it's going to be really small. I'm going to put a P on my PC so it will come to the middle of the sheet. So that's our logo. So I'm just going to zoom in again. There is space here to place the logo, but I don't want it to be that big and distracting. Alright, so I'm going to make it even smaller. Maybe make the height as 6 mm, so it will be small. And you observe that it's not a flipped image yet, so I have to flip the image. So I'm just going to mirror it horizontally, so when I transfer it onto the top layer, it's going to be in the straight form. So I'm just going to copy this again, and I'm going to paste it here. Oh, it got pasted there, so just going to bring it here. So where is it? It's here again, right? So I'm just going to zoom to this. I can't place it directly over this because it's all black, so I won't be able to see it. So I'm just going to put a box here. And I'm going to fill the box white in color, and I'm going to bring this to the top of the page so that it will be on top of the white box that I created, right? Maybe make the box a little bigger so it looks proportional to the logo itself. I'm going to position the logo in the center of the box using some shortcut keys. I'm going to group these two, move it along together. Apart from the logo itself, I actually want to print the content information, like the student's name and the name of the product and things. Usually we have the product name and the date, right? So we put those on the text. So I'm just going to say power supply, and I'm going to say 15/10/2020, but this I'm going to change it to white color, right? I'm going to change the font to smaller size, make it bold so we can place it here. Okay, why don't we just add the name of the student also, give him more credit for what he has done. He's done a fabulous job here. Now I'm just going to make it a little more fancy by center aligning and things like that. So Karthikeya's power supply, made on 15/10/2020 under the help with Kuruganti computers. So we have put our brand there on the bottom, and on the top we already have it. The only thing now is we have to flip this name also. So we are going to flip it. So when it prints, it's going to, when we transfer it onto the copper clad, it's going to be straight. Alright, so now it's ready. Now we can print this onto a photo paper. So I'm just going to save this as a CDR file instead of a PDF. Alright, so in Karthikeya version, power supply version 1. Oh, why don't we add that also here? We'll mention that this is for version 1 here, right? So we'll add that. Version 1, right? And I'm going to save this as a PDF, CDR file. The glossy photo paper is a little more expensive compared to the regular A4 size sheet. Each sheet here, if you want a top quality one, costs about 10 rupees a paper. So what we're going to do is to add multiple printouts. So if we fail in transferring one image properly, we can redo the heat transfer method to print again. And if we do print extra sheets which we have not used, we could have it as a spare for later use. So I'm going to I'm going to ungroup all these, and I'm just going to group individual pieces together. I'm going to place them in such a way that I'll be able to print multiple copies. So I'm going to top line them, group them, copy and paste one more set of documents. So these I'm going to center align, group them. I'm going to align them to the center of the page horizontally. Now this extra space on the bottom will get wasted, so I'm just going to print it on the bottom half of the sheet instead, so I can cut off the top half and reuse it for some other PCB in future. So I'm going to rearrange this horizontally. Alright, so I'll have to now load the glossy photo paper on the printer, and then we'll come back to printing. So let's continue the video from that point. Okay, now I have loaded the paper into the printer. So I'm just going to say print. I want to choose the laser printer. I have to change it to A4 and no watermarks, nothing, 100% normal size. Everything is in order. Okay, and print preview is going to show me the image inside the printable part area of the printer. So I'm just going to say print. Okay, I'm just waiting for the printing to start. Now it's in order, so we can move on. You can see that the sheet is glossy, and if you closely observe, wherever the printout has come, the ink is going to be dull black. That's basically the toner. Alright, and you can see that the image is a flipped version of what we need. Right, so when you transfer, the straight image is going to come onto the copper clad onto the top layer. Now we are going to cut this to the dimension that we need, and we are going to use that to do the transfer. Okay, this PCB is about 8.5 centimeters by about 5 centimeters, right? That's the size of the copper clad that we are going to cut from a big sheet of copper clad that we have. We need a copper clad piece which is about 8.5 by 5 centimeters. So this is about 6 centimeters wide, so I can use this piece. This is how a copper clad sheet looks. It's a huge piece of copper sheet which has got epoxy base, and then on top they have deposited copper. So I'll show it to you after we cut the piece. So I'm just going to, I already marked the 8.5 borders here because I don't want this extra piece, this piece to be used. So I'm cutting it off after that, and then we're going to trim it. I used a right angle tool to mark the things. I'm also going to score that line properly, so that when I use the angle grinder to cut it, it's going to be precisely on it. So I'm just going to score it several times using a marker. Marker is similar to a penknife, but it is meant for marking on metal. So if you see here, I've already made a dent on it. So I'm going to do something similar on this half also. Alright, so I've scored it. Now I'm going to use an angle grinder to actually do the cut. This is what an angle grinder looks like. So I'm going to use this to cut here and here. I'll start with the outer edge first. I'm going to do the other half also. I have the piece here. I'm going to file the edges so that this extra piece of copper that has come raised out because of the cutting is going to be removed. I'm going to remove that excess piece of copper. I'm going to file it off, and we need to now mark this to be about 5 centimeters. We're going to do that using a right angle. We are going to use a regular file to remove the abnormalities on the copper on the edges. It should not be sharp and cut you off. So we're going to make sure that doesn't have any excess copper on the PCB is going to be on the edges is going to be removed by this process. Okay. Alright, so this is the copper clad. So if you see this structure of the copper clad, we are going to have what we call epoxy. It's a plastic on the one side and copper put on it. The thickness of this copper is about 0.1 mm. This is what we have. It's not clean, so we need to do the next polishing. Now, after we get the copper clad cut into the size that we need, and then the edges trimmed properly, filed using the file, we need to polish this surface a little so that any non-copper residue on it is cleared. I already cleared it with isopropyl alcohol. The alcohol dissolves all the dust, but there is still some oxidized copper or something like that. So we need to remove that layer using something called steel wool. Right, this is like a smoother version of the scrubber that we use for our utensils. So I'm just going to take a small portion of it. Alright, and I'm going to rub it onto this. So I have a good shine on the copper clad. You can see the difference in the quality of the copper where I have polish and where the polish is not there, right? It doesn't even reflect where the dirt is. So we're going to use the steel wool to scrub all over. Based on the quality of the steel wool itself, how fine the scrubbing is going to happen will be determined. Because of the pandemic situation, I couldn't get the best quality steel wool. but still it's exposing the copper pretty well. So if you see now, the whole part is shiny, right? So this is the copper clad, and this is the bottom layer that we want to transfer onto the copper clad. So now you can understand that when we place it like this, and through heat transfer we transfer the image from the back of this onto the copper, you're going to get a straight image, right? That's why we had mirrored it, just in case you didn't understand it while I was explaining it earlier. Now we are going to apply heat on this side to transfer it. Usually we do that with a heat transfer, like we have something like a sandwich maker which can transfer the heat. Since that's not working right now, we are going to use a simple, pressing iron to do the heat transfer. Now placed it on a piece of granite, I'm going to use a simple pressing iron to transfer the heat. I'm just going to place it on top of it. I'm just using some cotton material to keep my hands safe. I have to first start pressing it on one side at least, so that the heat starts transferring the toner. Once it starts transferring this toner and the paper starts sticking to the copper clad, I can release it and I can continuously keep pressing it. It takes about, I have put it on max heat. It's on dry method. I'm not using any water on the iron. I'm just doing the heat transfer by continuously pressing on it. I'm allowing the heat to do the magic for me. We're going to do this for about 5 to 10 minutes, and then we'll move on from there. I'm just finishing up the heat transfer process. So usually all the markings that you see here are basically a good indication that enough transfer has happened on the bottom side. Alright, we are never 100% sure about what has happened on the bottom, but with experience we know that these markings are a good indicator that the transfer has happened properly. And we are going to now allow this copper clad to cool down a little, and then we are going to use some pliers to move this, take this piece and put it in some water. I already have water in this, though it's plastic, the water is there to absorb all the heat. So I'm just going to dip it in water, and I'm going to leave it there for about 10-15 minutes, so that the paper will come loose, but the ink on the paper, the toner, which is already, because of the heat transfer, has already got stuck to the copper clad. So it's easier to remove the paper. Basically, I'm trying to eliminate any addition between the glossy side of the paper to the toner itself. So the toner gets completely deposited onto the copper clad. So we'll just wait about 5-10 minutes, and then we'll then try to remove the paper. We have allowed the copper clad to soak in the water long enough. So when we start removing it, the sheet starts coming off pretty easily. So I'm just scrubbing it off. Initially we don't do a scrub directly. It has soaked long enough to come out on its own. So I'm just removing the part like this. Right. We'll just allow it to stay in water, and we can also use a gentle scrubber like what we use for dishwashing to remove the paper from the copper clad. There is enough adhesion between the toner and the copper clad, so even if you use a scrubber, you're not going to lose the toner from the. I'm actually pressing it pretty hard with my hands, with my fingers. The ridges on my fingers were good enough to remove the paper, right? So if you see, I'm able to remove all the paper. I'm just getting it a little more wet to eliminate it. Though the process looks very crude, it is pretty straightforward. Just getting a little wet so I can remove any excess pieces of paper. Right. So like we have been discussing over and over again, all the text is in straight. No tracks have been badly transferred. There is some text that has not transferred properly. We can probably write it down with a marker. Any missing parts here, anything that is not done, any proper transfer that has not happened, we can always fix that with the markers. Right. So all right, so that's about it. Anything that didn't get transferred properly when we did the heat transfer can be corrected using a marker like this. All right. I'm just going to write with a marker. For example, here I'm just going to say -V. All right. I'm just adding this to show you that this will work. That's all. I don't really need it because I have the PCB for reference anyway, and it's not a significant way. It's not like a track or anything, just a text. All the tracks have got deposited pretty well. Another thing to observe is that the color has slightly changed because on top of the toner there is also some residual paper. That's fine. When we do the etching and then we remove the toner, that paper will also go away because the toner is what is making the paper stick to the copper clad here anyway. So to do the etching itself, we have taken some ferric chloride and we have put it in some, dissolved it in some water, and I have poured it into a bath. What we are going to do is we are just going to place the PCB in the ferric chloride. We are going to allow the ferric chloride to do the etching for us on the PCB. So we are going to allow it to start etching. For the PCB this small, it probably takes about 5 to 10 minutes of etching, nothing more than that. You can already see on the edges that the copper is starting to come off. It's a chemical process that's happening here, so we're doing it that way. We have removed the PCB from the ferric chloride solution and we have washed it under a running tap with plain water and we have wiped it dry. Now we are checking if the PCB has been etched properly. So these are the holes are the pads, so we can see that all the pads have been properly etched, and everywhere else where the copper has to be removed has been removed, right? And now under this toner is all copper. So we are satisfied with the etching now. So we'll move on to the next. Now that the etching has been completed to our satisfaction, we are going to remove the toner by using a thinner. It's basically like a nail polish remover. I have soaked the cotton ball in thinner and I'm just going to erase it. We have to allow it to soak a little before it starts coming apart. Right? So once it soaks enough in the thinner, all the toner is going to get removed. We need to expose the copper so that we will be able to solder our components to the PCB. You can see that the toner has been removed now and the copper is completely exposed. The thinner will dry away anyway because it's basically kind of alcohol. Even a nail polish remover is good enough to do that for us. Alright. So now the PCB is ready for the drilling and continuity testing and soldering. The next step would be to drill holes for these pads. Now on this PCB there are two sizes of holes. Components like resistors that have 0.8 mm holes, IC base which has 0.8 mm holes, and components like diodes which have a 1 mm hole, and RMC connector which has got a 1 mm hole. So we are going to drill 0.8 mm holes first, and then we are going to drill 1 mm holes. After all the holes have been drilled on the PCB, it is aligned against the silk screen with reference to a light source. Once everything is properly aligned, this is also pressed onto the top layer using the same heat transfer method that was used for the bottom copper. Here's the PCB with the silk screen also heat transferred onto the top layer. Now we can see that the edges are not aligned with the outline that we drew on our CAD tool. So we are going to file those using a filing blade on the angle grinder. Here is the final PCB ready for use in our power supply.